So we've learned how to add vectors that are collinear. In other words, they're all in one direction. And we also have learned how to add vectors that are perpendicular. So what if they're neither perpendicular nor collinear? So I'm going to do some obtuse vectors here. So they can make an obtuse. In other words, I'm going to have two vectors. So I'm going to imagine I have an object here, and I'm pulling on it in this direction with force 1, and I'm pulling on it in that direction with force 2. Okay, and so force 1 is a little bit bigger than force 2. And so I'm going to say that force 1 is an angle of 20 degrees relative to the x-axis. And I'm going to say this is an angle of 75 degrees relative to the x-axis. And I want to know, how do I do this? Well, rather than calling them force 2 and force 1, I'm going to use the notation we've been doing and call them vectors A plus B. So when we go in this direction plus this direction, that's going to be a final result like that. So the result of adding these two things is going to be A plus B. Okay. Well, how would we actually draw this out? Well, way you draw this out is you've got vector A right here at 20 degrees. Now we always draw them nose to tail. So the next vector is going to be right here, and vector B is going to be at 75 degrees. Okay, now let's say in order to answer the problem, you need to know the magnitudes of these things. So let's say the magnitude of B is going to be 14 degrees, and it's going to be at the 75 degrees. And magnitude of A is going to be, let's say that's 22 newtons, or 14 newtons at 75 degrees and 22 newtons, and that's going to be at 20 degrees. And so the resultant there is going to be A plus B. So how do we do that? Cannot use Pythagorean Theorem with A and B, but we can use the law of cosines. Law of cosines says that if I call this angle inside the triangle opposite R, if I call that angle phi, then R is going to be equal to the square root of the other two sides squared minus 2ab cosine phi. Now notice that if phi happens to be 90 degrees, in other words, if this is a right angle, the law of cosines reduces to simply Pythagorean theorem. Okay, so if we plug in the numbers that we've got here, then R square root of 22 newtons squared plus 14 newtons squared minus 2 14 newtons, 22 newtons, cosine. Well, we got to find phi. How do we find phi? Well, if that's 75 degrees, then this right here between vector B and the horizontal is going to be 105 degrees, and that's 20 degrees if this is 20 degrees, so that means that phi has to be 125 degrees. Okay, so R comes out to be 32.1 newtons. We don't want just R, we want to know what angle is it. So back to our problem here. So we got A, we got B, we got R. Well, this angle right here we said was phi, so I'm going to call that psi. Okay. Now, law of sines says that the sine of any angle divided by its opposite side in a triangle is equal to the sine of any other angle divided by its opposite side. So that means that we can say that psi is going to be the inverse sine of B sine phi over R. Well, we know all those factors. We know, therefore, that psi is the inverse sine of B, which was the 14 newtons, okay, sine 125 degrees, and divide by 32.1 newtons. So psi comes out to be 20 40.9 degrees. Well, I don't want that. I actually want this angle right here, theta. Well, if this is 20 degrees, then that means that theta is going to be psi plus 20 degrees. So theta is going to be equal to 40.9 degrees. So we could say that R is going to be equal to 32.1 newtons at an angle of 40.9 degrees from the x-axis. Okay, so we solved the problem. But we solved the problem using all those trig identities, which is kind of cool. Remember back when you were in a trig class and you had whoever was teaching you trig said, you ought to learn these trig identities because one of these days you're going to need to know them. Well, guess what? That day's come. You needed to know a trig identity. Okay. And so trig relation. So go back and email you whoever taught you trig and say, hey, you were actually right. I did need to know that one of these days. Okay, but there's another way of solving the problem. Another way of solving the problem that doesn't need the trig at all. Because if you remember, we've got a vector right here, A, at 20 degrees, and a vector right here that's at 75 degrees, vector B, and we're trying to find the result. Well, remember, vector A can be written in component form. So it's going to be the length of A cosine 20 degrees I plus the length of A sine 20 degrees J. Vector B is going to be B cosine of 75 degrees I plus B sine 75 degrees J. Now, we know that A is 22 newtons. We know that B is 14 newtons. So if you plug that into that equation there, then vector A is going to be equal to 20.7 newtons I plus 7.52 newtons J. Vector B is going to be equal to 3.62 newtons I plus 13.5 newtons J. Okay. Well, R is A plus B. So that's going to be equal to 20.7 newtons I plus 7.52 newtons J plus 3.62 newtons I plus 13.5 newtons J. Well, this is an algebra problem. Okay, you've got this and this both as coefficients of the I, and you have this and this both as coefficients of the J. So R is now going to be equal to 24.3 newtons I plus 21.0 newtons J. That means 24.3 newtons in the x direction and 21.0 newtons in the y direction, and so x and y are perpendicular to each other. So to get R, you just use Pythagorean Theorem. 24.3 newtons squared plus 21 newtons squared. Take the square root of all that, and so R comes out to be 32.1 newtons. Same that we had before. Well, of course it's the same as before. It's the same problem. This is a different way of solving the same problem. What about the angle? Okay, so there's theta. To get theta, then that's going to be the inverse tangent of 21 newtons over 24.3 newtons. So this comes out to be 40.8 newtons. And so we would then say that vector R is 32.1 newtons at an angle of 40.8 newtons from the x-axis. And that is same as before. I think before we had 40.9 degrees, but this is our least significant digit right there. So it rounds the same. So within rounding error. So these are two ways of solving exactly the same problem. Now, one way is using the triangle relations. The other way is using components. Now, with the triangle relations, you can only add two vectors. So you can add a vector, you can add another vector, and you make a triangle with the result. So only two vectors can be added with a triangle. On the other hand, with the component method, you could have a vector, have another vector, have another vector, have another vector, have another vector. And then the result can be like that. So this vector has x and y parts, this has x and y parts, this has x and y parts, that has x and y parts, that has x and y parts. So the Rx is just the sum of all the x of all the i's. Okay, so that's the sum of all the i's. Okay, and the Ry is just the sum of all the j's. Okay, and so now you have the total x and the total y. You have the total x, the total y. Okay, now Pythagorean theorem. So with this, you can add two vectors like we did, or three vectors, or four vectors, or five vectors, as in this picture right here. You get five vectors added together to make the resultant, or you could add 10 vectors, or 20 vectors, or even Avogadro's number worth of vectors. Well, actually, couldn't really do that because there'd be no computer capable of handling that big of a number. Okay, but in principle, there's no upper limit other than time and computing power to figuring out all of the components. And so that's how you do it. Now, really, this is how you normally do vectors. Very rarely do you actually use the triangle relation, so you can, so you can do that, but you're limited, whereas this doesn't limit you at all. And so some of you have calculators that will add vectors for you, and so when you enter the vectors into the calculator, what's happening is your calculator is finding the x and the y and sometimes the z components. Right now we're just doing x and y here, but we could have had a z component in here, a k component. And so your calculator will actually break it into the x and the y and the z components, and then it adds it in this fashion. All the other things you do with vectors, multiplying, dividing, subtracting, it breaks it into components and handles it in that fashion. So while I told you about the triangle method and the law of sines and cosines, that's really not how you normally do it. You can if you really feel like it, but really it's the component method that is the dominant method behind solving vector problems.